Everyone, welcome to this session on MongoDB, projections, indexing and aggregation. I am Suguna, Assistant Professor from the Department of Computer Science and Engineering at SNS College of Technology. Today, we are going to understand how modern applications handle huge amount of data in an efficient way. So, let me start with a simple icebreaker question. Imagine opening an Instagram and it loads instantly, but there are millions of posts in the database, right? So how does it fetch only what you need so fast? So the answer lies in three powerful concepts, which is projection, indexing and aggregations. So let me introduce a problem statement for you. In a real world application, we deal with huge amount of data, slow queries, unnecessary data fetching. So what we need to improve the performance, fetch only the required data, and we have to analyze the data in an efficient way. So let me empathize that. So let's understand from both user and developer point of view. So user wants fast loading application and they need only the relevant data what they are searching. Developers struggle with slow database queries, heavy data processing. So clearly there is a gap we need to solve. So let me understand the challenges in this problem statement. So the main challenges are fetching the full data makes the system very slow. Searching large data set is very inefficient. Complex calculations take much more time. So how do we solve this? So we use three main technique that is we discuss in this ideation part. So three main techniques are projection. So what is projection? This helps us to select only the required field by the customer. Example, instead of fetching the entire document, we fetch only the name and price. The second key technique is indexing. This improves the speed of search operation. How does it do? It works like an index in a book, helping us to find the data in a very quick manner. The third technique is the aggregation. So what is this aggregation? It is a process which is used to analyze and also to process the data. For example, counting the total items in a cart, calculating the averages and generating the report. So we had seen three techniques, right? So the final idea is we can combine all these three techniques in order to get an optimized database performance. Now let's move on to the prototype workflow. Now let's see how this works in a simple application workflow. We take input from the user, we process the whatever the input which is given by the user, and we will return the filtered results in a very efficient way. So this is how the MongoDB database works. So I hope this diagram will clearly explain you how the user requests are handled by the server. And next, this is the prototype application. So here is a simple HTML form where the user can enter a category. They click on the search and the results will get displayed. This is how user interaction starts. So now let's see the backend logic which is using the MongoDB aggregation. We perform three steps. First step is match. That means we have to filter the products which prices are greater than 500. Next operation is the project. We select only the required fields like name and price. The third operation is sorting. We have to arrange the results in a descending order, that is from highest to lowest of the prices. Finally, we send the filtered data as the response. And this is the prototype outcome. What is the result? It is fast, clean and optimized data output. So these are some of these applications. So these concepts are used like in real world applications like e-commerce. So in e-commerce, it shows only the product details which are required by the customer. And next in the social media. So social media, it helps for faster loading of the feeds, posts and articles. And the third one is for analytics of the data dashboard, which is nothing but analyzing the dashboard. That means generating the summaries and reports as required by the customer. So after implementation, we need to test the system in order to ensure whether the queries are fast, the output is correct, and the performance is improved or not. I hope you understand this projection, indexing, and aggregation using our design thinking approach. So let me give on a hands-on task. So try this hands-on task. Okay, you just create a collection. You just perform projection, show only the name and price, and you index. That means you have to create an index on name. And for aggregation, you can go for counting the total items. So you just try this hands-on activity. Okay. So to conclude this, the projection will reduces the data overloading. Indexing will improve the speed and performance. Aggregation will helps in analyzing the data in an efficient manner. Together, they make the MongoDB as a powerful and efficient tool. So, thank you for watching. If you found this useful, you can like me. If you have any doubts, you can provide me on the comment section. So, thank you all for watching this video. Thank you.